Assalamu alaikum dear students, I'm Mansur Ali, lecturer of mathematics APDC. Okay dear students, now it's all about composition of functions. So how we can define that if we have a function from x to y, means from set x to set y there is a function f and another function g from y to z, then composition, this is spelling error, so this is the right one. The composition of f and g is a function defined by g of f from x to z and is defined by g of f of x means g of f of x or g f of x means first we have the value set a, set b, okay. Now there is a application that set a to set b, that is function f, so we can say that this is g of f. Then it means that function is applied to the a, so this is now f of a. And again from set b to set c, or we can say that from the definition what I read, x y z, so we can say that this is x, this is y, this is z. So from function y to z, there is another function set function g. So f of a is applied to the function g, so g f of a. So we can say that from a to c we can say that g of f, g of f. So this is the definition of composition of function. Okay. The actual problem of the students in exercise 1.2, there is question number 1 from exercise. The real valued function f and g are given below. Find f of g of x, g of f of x, f of x and g of x. Okay, there are some parts, part 2, part 3, part 4 are homework. Okay, part 2, part 3, part 4 are homework and I am doing part 1, and from this thing you can do easily part 2, part 3, part 4. Okay, now look at this. Function f of x is equal to 2x plus 1 is given, okay, and second function g of x 3 upon x minus 1, that is given also, and the condition is also given, x is not equal to 1. Why? Because you know very well from previous lectures that if we put x is equal to 1 here, so 1 minus 1 0 and 3 upon 0, that is undefined. So x, we cannot put x is equal to 1 because function tends to undefined. So there are two functions, f of x and g of x. Okay, so now if we have f of x and g of x, first one a part, this is a part answer, whole one. Okay, f of g of x, f of g of x, what can I write? F g of x means f is outside, g of x, f is outside, g of x. What is g of x? 3 upon x minus 1. So now the value of x is 3 upon x minus 1. I again saying that the value of x is now 3 upon x minus 1. Now f of 3 upon x minus 1. Okay, where is f of x? There is f of x. 2x. What is the value of x right now? 3 upon x minus 1. So 2, 3 upon x minus 1 plus 1, and by the sake of simplification, after simplification just take the LCM. So 2 3 is 6 and x minus 1 is in the denominator, so 6 minus 1 is x plus 5 upon x minus 1. This is the answer of this first part, f of g of x, x plus 5 upon x minus 1, or we can say that there is another function, okay, composite function. Okay, now g of f, second part b, g of f of x means g is outside and f of x. What is g is outside? What is f of x? F of x is 2x plus 1. Okay, now the value of x is 2x plus 1. The value of x is 2x plus 1. So g of 2x plus 1 means g of x. What is g of x? 3 upon x minus 1. So 3 upon x, the value of x is 2x plus 1, minus 1 is same. So 3 is same, 2x plus 1 minus 1 we can cancel, so 3 upon 2x, this is the answer of B part. And f of x means f is outside and f of x is inside. So what is f of x? F of x is 2x plus 1, this is 2x plus 1. And again f of x means 2 times 2x plus 1 plus 1. So 2 to the 4, 4x plus 2 plus 1, and 4x plus 3 is the answer of C part. Now last part, g of x means g of x. G outside, g of x is 3 upon x minus 1. Okay, now this is x. Again this thing I can put this x. So 3 upon x minus 1. 3 upon, I took the LCM, 3 minus x minus 1 upon x minus 1. After the simplification, this is the answer. Okay, so there is another topic, although that it is the topic of 1-to-1 or on-to is all about first year, but why I am repeating, because for the inverse function that I left in lecture number 1-2, why I left, because of this, because of inverse function, the function should be bijective, and for bijective function should be 1-to-1 and on-to, both should be we can say that both should be applied. Okay, so 1-to-1 means injective function. Okay, injective function I can make you understand with the help of example. Now look at this. This is function f x plus 2. Okay, x plus 2. Okay, if I put x is equal to 1, then 1 plus 2 is equal to 3. So f of 1, the value is 3. F of 2, the value is 4. F of 3, the value is 3 plus 2, 5. This is the diagram, and the function is here. Now 1 is mapping to 3, 2 is mapping to 4, and 3 is mapping to 5. Okay, so now what is the domain set? 1 2 3. 1 2 3 is the domain set, and range set is 3 4 5. 3 4 5. Okay, now look at this. What is this? A function f x to y is said to be 1-to-1 if distinct pre-image, this is called 1 2 3 pre-image, if distinct pre-image domains elements of belongs to x, means ye wale have distinct images, means codomain image. Distinct pre-images have distinct co, so that is called 1-to-1. Okay, so x plus 2 is the 1-to-1 function. And for the hint, for the trick, because maths is all about tricks as well, so French word injective means at most 1. At most 1 means के maximum, you can say that बोलते हैं ना हम उर्दू में भी कि ज़्यादा से ज़्यादा. ठीक है, तो in French word injective means at most 1, and the second one onto, the meaning is at least 1. ठीक है, so at most 1 means every member, हर कोई, every member should be mapped to another distinct element. Okay, now onto, that is surjective function. Why I am just giving this presentation, because of we have to go to do the bijective function. Onto function means surjective function. A function f x to y is said to be onto if at least, again, at least every codomain, at least every codomain means this one. So domain element, that is why 2 4 6 is related with 1 or maybe more than 1. Maybe more than 1 means कि it can be associated with 2 members of this as well. Okay, for example 2x. So 2x means that 1 comma 1 comma 2 2 comma 4 and 3 comma 6. Okay, so 2x is onto function. Why? Because for example if I write that is for example I can say that 8. Okay, so 8 is, for example if I write here 8 either. Okay, so at least every codomain means every codomain should be mapped to the this thing. Okay, now bijective function. Bijective is 1 to 1 and on to all both. Okay, so both the thing that bijective is 1 to 1 and on to. A function x to y is said to be bijective if it is both 1 to 1 and on to. French word bijective means both injective and surjective. Bijective function is also called invertible. जहाँ पे हमें आना था. Okay, this is the thing that we have to reach it. Invertible. Only bijective function can have inverse. This is the second year topic. ये second year topic है. ठीक है. So for example, let x is equal to x plus 2. So function is bijective. Why? Because the same example that I have showed in the previous slide. X plus 2, that is 1 to 1 as well and on to as well. Why? Because every element is mapping to distinct element and every codomain element at least map with the domain element. So x plus 2 is 1 to 1 and on to, so it means that x plus 2 is bijective function. Okay, now inverse of a function. Inverse of a function means inverse of a bijective function, that is if function x to y, then it is known by f inverse, that is inverse of function, and y to x, and defined as f of x is equal to y for all x belongs to capital X, and f inverse y, that is x, for all belongs to capital Y. So this is the thing that f inverse, if you compose it with f to f inverse, that is x. Okay, and again the same thing, f inverse x to the f, that is x. Okay, now this is the again question from your exercise. Find the real value function f defined below. Find f inverse x, f inverse minus 1, and verify that f inverse x is equal to f inverse f of x is equal to x. So this is the whole question. Okay, and homework is part 3, part 4. I am doing part 1 and some part of part 2. But for the part 1 you can learn every aspect of this question. F inverse x, f of x is equal to minus 2x plus 8. Okay, now how we can find f inverse x? First, what is the value given? F of x is equal to minus 2x plus 8. Okay, and f of x is equal to y. Let f of x is equal to y. So it means that f of x ki jagah what can I put? Y. So y is equal to minus 2x plus 8. Okay, now I am just making a subject of x. Okay, so y minus 8. Okay, minus 2x, I'm just moving from here to there, so 2x, and 8 minus y. Okay, so 8 minus y and upon 2. So this is the inverse element. So x, 8 minus y upon 2. So f inverse y, that is x. So f inverse y, that is 8 minus y upon 2, and then replace y by x in the above equation. So f inverse x is equal to 8 minus x upon 2. So this is the answer of part A. Now part B, f inverse minus 1. So do you know f inverse x? Yes, we know. So what can we put? Minus 1. So x की जगह क्या put कर देंगे? Minus 1. Okay, 8 minus plus 8 plus 1, 9 upon 2. This is the answer of f inverse minus 1. Now verify f inverse x of f or f inverse of f of x. It should be equal to x. Okay. Now f of f inverse x. What is f inverse x? This is f inverse x. That's why I make you understand first composite function. Okay, f of 8x minus x upon 2. Okay, now what is the value of x right now? 8 minus x upon 2. F of x, where is f of x? There is f of x. So minus 2 x. What is the value of x right now? 8 minus x upon 2 and plus 8. Okay, now we can cancel 2 by 2. So minus with the multiply, so minus 8 plus x plus 8 minus 8 should be cancelled. So now look at this, what I remain? Only x. So f of inverse x is equal to x. This is equation number 3. Now for this part, first one, f inverse f of x. Okay, f inverse is outside, f of x. What is f of x? Minus 2x plus 8. Now f inverse of something. Okay, so what is f of inverse of x? Now what is the value of x? Minus 2x plus 8. So 8 minus 2x plus 8 upon 2. After simplification we get again x. So from equation number 3, equation number 4, we have proved that f of inverse x is equal to x. This is part 2. Another, f of x is equal to 3x cube plus 7, f inverse x, and all the things that you have learned from part 1. Please do it as yourself. Okay, so this is f of x, again f of x. So you can just just make a subject of x, and this is by the replacing f of inverse x. So this is the thing. Okay, now question number 3, without finding the inverse, find the domain and range of f of x. There are two parts. Okay, now this is in the under root, so it means that the value should not be in negative sense. So minus 1, minus 2 cannot come because it is in under root. Okay, for the domain, for the x. Okay, now for example, if I put minus 3 here, x की जगह minus 3 plus 2 minus 1, under root minus 1 iota, imaginary number. So I have to take a limit that it should be minus 2. So minus 2 plus 2, 0 root 0. So from minus 2 to infinity we can put any number, but beside minus 2 we cannot put. Okay, minus 3, minus 4, minus 5 and so on we cannot put in function of x. So domain is minus 2 to infinity. Okay, if you put, for example, minus 2 plus 2, 0 root 0. Okay, again minus 1 plus 2, 1 root 1. Okay, so you will start the range, all set of all real positive numbers, means every number should be positive in the range. Okay, and domain of f inverse, for example, f inverse you need to find, and 0 to the domain of this, is minus 2 to infinity. So it will become range. Look at this. The domain of set of this, it will be range of the inverse of the thing. Okay, and 0 to infinity. Why? Because it is a range of all positive number, that is 0 to, so it will be the domain of this, and the same as here. So I cannot put 4 here. Why? Because 4 minus 4 is 0, and something upon 0 is undefined. So all real numbers minus 4, that is domain. So the range of inverse of this is real number minus 4. Okay, and what you can get, all real number. For example, if you just seek the domain of this, so the range of this is all real number plus 1, means for example, if I put 4 here. Okay, so yes, so plus 1, if I put plus 1 here, so plus 1 minus 1 is 0. Okay, so the domain is just convert to the range, and range to convert to the domain. If you have any question, so you can ask me. Today's lecture is something complicated, but after practicing from the exercise, you can learn the concept.
Thank you for your attention, your participation. Allah Hafiz.